Hello and welcome to all. In this lecture, we are going to discuss closure and decision property of the CFG as well as application of the contest free grammar. So first of all, we will see the closure and decision properties of CFL. So decision properties of CFL. Here, this decision algorithm takes an input instances of the problem and then determine whether the answer of that instances is yes or no. Okay. So decision in case of decision algorithm, we are having some input, and with that input, whether we are getting the answer as yes or no, so that will be that decision will be taken. If for the problem such decision algorithm is exist, if for the problem such decision algorithm is exist, then that particular problem is called as decidable problem. Otherwise, it is called as undecidable problem. Okay, if a decision algorithm is exists, then we can say that it's a decision problem. Otherwise, it's a decidable problem. Otherwise, we are going to say that it's a undecidable problem. Now, based on this, there are two properties of the there are two decision properties of CFL is there. Sometimes it is also called as algorithm regarding to CFL. So first property is nothing but whether the CFL, we have to determine whether the CFL is empty or not, and second is nothing but CFL is finite or infinite. So first one, algorithm to determine CFL is empty. So how to determine CFL is empty? First of all, we need to construct. We have to construct. We have to construct the algorithm to test whether the CFL is empty or not. For example, G is equal to VTPS. Here we are going to say that the given language grammar is non-empty if and only if the start symbol yes generates some string of symbol. If some string of symbols are generated with the help of start symbol, then we are going to say that grammar is non-empty. For example, we are having A. Okay. After that, A tends to small a or epsilon. So here start with the help of this starting symbol, we are able to generate some string of terminals. Okay, maybe s tends to a, we can generate twice a, we can generate 3a, 4a, 5a, like this. So such as these strings are possible, that's why the given grammar is non-empty. If strings of terminals are not possible, means like this, s tends to a, s tends to a, where a tends to b, this type of grammar. Now strings of terminals are not possible. Okay, here we cannot generate strings of terminals, so such a grammar is called as, or such a CFL is called as empty CFL. Okay, now second one is nothing but algorithm to determine CFL is finite or infinite. So when we are going to say that CFL is finite, if CFL is finite if it is in simplified form. Simplified form is nothing but if it is free from unit production, if it is free from useless symbol, if it is free from null production. Such type of grammar is called as simplified grammar, and if the given grammar is in simplified form, then CFL is a finite one. If otherwise CFL is infinite, means if the given grammar is not in the simplified form, means it may contain some useless symbol, it may contain unit production, it may contain null production. Such type of CFL is infinite one. So these are the two properties of decision properties of CFL. One is algorithm to determine CFL is empty, another one is algorithm to determine CFL is finite or infinite. Now closure properties of CFL. So CFL is closed under three properties. One is union. CFL is closed under union operation, CFL is closed under concatenation operation, and CFL is closed under the clean closure operation. So we'll see one by one. So first of all, CFL is closed under the union operation. So here let us consider there are two languages are there. L1 and L2 are the two CFL contest free languages. Then L1 union L2 is also a CFL, means it should be a contest free language after taking the union of these two languages. So we'll try to prove it how it will be. Means union of these two languages is also CFL or not. Let L1 be the CFL. L1 is a language which will be a CFL and generated with the help of grammar G1, where G1 is represented with the help of four tuple V1, T, P1, S1, where V1 is the number of variable which are required to generate the grammar G1, T's are the terminals for the grammar G1. T1 is nothing but set of production or equation of the grammar G1 which will generate the language L1. Okay, and S1 is the starting symbol of the grammar G1. Same way, L2 is another language, another CFL language which is generated by using grammar G2, where G2 is represented with the help of 4 tuple. V2 are the set of variable for G2 grammar. T is the set of terminals. P2 are the production of the grammar G2, and S2 is the starting variable of the grammar G2. Now let us take the union of these two grammar G1 and G2. That is nothing but, first of all, we need to take the union of the two languages, L1 union L2, that is shown here. Okay, we have to take the union of L1 union L2. So L be the language which is generated by using grammar G. G is equal to, which is shown by using 4 tuple VTPS, variable, terminal, P, production, and S is the starting symbol of the grammar G, which represent the language L. Now S is the start symbol, so of the grammar G. Therefore, two new production we need to add here, because S may contain, as it is the union of L1 and L2. So S may start with S1 production, means L1 language, or S may start with S2, which is the starting symbol of G2 grammar. Now then we have then the grammar G will be VTPS, which V is nothing but V1 is the set of variable of the grammar G1, union with V2 set of variable of the grammar G2, and union with S starting symbol of the grammar G. P is nothing but set of production P1 union with P2. P1 are the production of G1 grammar, P2 is the production of G2 grammar, and here it will be union with S tends to, either we need to start the production with S1 or S2, because it's a union and S is the starting symbol. So with the help of S, means starting symbol of the grammar G, we can generate a string of terminal selecting either start symbol S1 of the grammar G1 or start symbol S2 of the grammar G2. So S can generate a string of L1 and L2. Therefore LG, means language of grammar G, will be equal to L1 union L2. That's why it is closed under the union property. Now CFL closed under the concatenation. So second one is, it is also closed under the concatenation. So in concatenation, what? Let L1 L2 are the two CFL, then L1 dot L2 is also CFL, that we want to prove. So L1 is the CFL which is generated by grammar G1 with the 4 tuple V1, T, P1 and S1. L2 is another CFL which is generated with the help of grammar G2, which is represented with the help of V2, T, P2 and S2. Now let us take the concatenation of these two grammar G1 and G2. Then it will be L1 dot, it should be dot, sorry. Here it should be dot. Okay, L1 dot L2, where L is the language which is generated by grammar G. G is equal to VTPS, and S is the starting symbol of the grammar G. Okay, which will represent language L. Therefore, two new production we need, here we need to add the production of new production, that is nothing but S tends to S1 dot S2. That production we need to add it. So now after taking the concatenation, G is equal to VTPS. V is nothing but V1 set of variable of G1 grammar union with V2 set of production of another grammar G2 and S, where we need to add the production P1 are the production of the G1 grammar union with P2 are the production of G2 grammar, and S tends to S1 dot S2 there, and S is starting symbol. So S can generate a string W of the form W equal to W1 dot W2, where W1 is the string which belongs to language L1 and W2 is the string which belongs to the language L2. So it will start with W1 and end with W2. So S can generate string of L1 dot and L2, that is equal to L1 dot L2. So it is closed under the concatenation. And third property is clean closure. So here let L1 be the CFL, then L1 star is also means if you take the closure, then it is also CFL. So CFG G1 is equal to V1 comma T P1 S1, where V1 is the set of variable for G1 grammar, T terminals, P1 is the production, and S1 is the starting symbol of the grammar G1. Then L is equal to L1 star, means we want to take its closure. So L is the language is generated by using L is the language which is generated by using the grammar G. G is equal to VTPS, and S is the starting symbol of the grammar G. Therefore, we need to add the new production here. S tends to SS1. We want to take its closure. Okay, where and S tends to epsilon. Closure means we know that close it will include the epsilon as well. Any number of given input argument, including null. So we have to add these two new production here, S tends to SS1 or S tends to epsilon. Then the grammar G is equal to VTPS, where V is equal to V1, set of variable of the V1. P is nothing but P1. Here we need to add one more variable here, S as well. Okay, V1 and S. P1 union with S tends to S1, SS1 or epsilon, where P1 are the production of the V1, G1 grammar, and S is starting symbol. So S can generate string of L1. So LG is equal to L1 star, and it is closed under the clean closure property of the CFL. Now we'll see the application of CFL. There are three applications of the CFL. One is parsing technique. After that, it will be useful in markup language, as well as it will be used in XML and document type definition. So what do we mean by parser? So parser, here we will going to generate the parse tree with the help of given grammar. Okay, and for that parsing technique will be used. Reduce each multi-symbol sequence that represent a single object to be token. The translator next task to analyze the pattern of token. Such analysis is called as parsing, and it will be done with the help of parser technique. Okay, we are having some form of token, and that with the help of that token we are going to draw the parse tree, and that analysis will be done with the help of parsing technique. Okay. And like this, there are two more applications are there related to the CFL. One is markup language, and another one is nothing but the XML or document type definition. So markup language here, HTML hypertext markup language is one of the popular markup language. Main two function of this language are nothing but create link between document and describe the format of document. So CFG is used to describe legal HTML document and guide the processing of the document. Here some syntax will be used for HTML language, like P paragraph end with /p. Okay. So this will be the starting and this will be the ending of that particular paragraph. Like this, if you want to make it as a bold, or there are number of syntax are there for HTML or markup language. And third application is XML and document type definition. The purpose of document type definition is to define the legal building block of the XML document. It defines document structure with list of legal elements. DTD means document type definition can be declared inline in your XML document or as an external reference. So these are some applications related to CFL. We'll stop here. Thank you.